Hey class, this is Gigi from Kauai Community College. We are talking about the definition of a vertical asymptote. And this is the practice infinite limit question number 10. Okay, so the definition of a vertical asymptote is x equal to a is a vertical asymptote if one of these things happen. If the limit as x goes to a from the left or from the right of f of x is going to be either a negative infinity or a positive infinity. So you have to consider all of the cases when these things happen. Okay, and you only need one of these cases to occur for x equal to a to be a vertical asymptote. So when looking at this function, we would say, let's go ahead and see if we can factor and do something clever about this here. So numerator 14, 9, so I'm thinking 7 and 2, x minus 7, x minus 2. The denominator is with positive 6 at the end, negative 5 in the middle, so I'm thinking x minus 3, x minus 2. So what happened there? What happened there is we can reduce. Okay, so we can reduce this right here. So then our function is going to equal to x minus 7 over x minus 3 with a whole. Where is a whole? A whole is at x equal to 2, and y would be whatever the y value would have been if we are using this function here. So when we plug in 2, we'll have negative 5 on the numerator, and we'll have negative 1. Negative 5 divided by negative 1 would be a positive 5. So the whole is at 2, 5. And what is left is something that you should consider as a suspect for the vertical asymptote. Okay, so we are going to take a look at what happened. The limit as x goes to 3 from the left of f of x, and then we are looking at the limit as x goes to 3 from the right of f of x. So when x is approaching 3 from the left, we will have a number that is less than 3. A number that is less than 3 minus 3 is going to give us a negative small. And then 3, a number that is close to 3 minus 7 is going to give you roughly negative 4. So we can say negative divided by negative is a positive. 4 divided by a small number is going to be infinity. Therefore, the line x equals 3 is a vertical asymptote for this function. Okay, so you only need one of those cases to claim 3 as a vertical asymptote. But if you really want to know the behavior near the vertical asymptote, then you should look at both sides. So let's go and take a look at the other side as well. When x is positive, approaching 3 from the right, okay, when x is approaching 3 from the right, not positive 3, but when x is approaching 3 from the right, x is a number a little bit bigger than 3. A little bit bigger than 3 minus 3 is going to be a positive small. And then the numerator will stay roughly negative 4. Then negative 4 divided by positive small is going to be negative infinity. Okay, so then again, from here, we would say x equals 3 is a vertical asymptote. Now, what's more interesting is to be able to tell the behavior of the function near 3. So 1, 2, 3. What we know so far right here is x equal to 3 is a vertical asymptote. And so when x is approaching 3 from the left, our function goes way up, and then approaching 3 from the right, our function goes way down, right? And if we know where the horizontal asymptote is and the x and y intercept, we could actually finish sketching this graph. Oh, and actually what we also know is the hole. The hole is at 0, 5. So however your function look like, it's going to cross that hole at not 0, 5, but 2, 5. Okay, so I think your graph is going to look something like this, right? Skip over the hole, and then the horizontal asymptote is going to be at 1, I think, so it's going to look like that, and then it's going to look like that.